Hi everyone, this is Jude, and in this video I'm going to demonstrate the operation of my full controlled microprocessor circuit for my last demo 9 in this class. This circuit runs through 4 states, which is idle, load B, load A, and store. You can see those handled in the state memory and the decoder section. I've labeled the major components in red. Here's the address generator, the processor with the ALU that we built in this previous circuit over here. And then we got the state memory, the controlled next state logic. And we have, this is the mode that we're in, like the state that we're going to be moving in from idle to load B to load A to store. You're going to see how this is going to move when we start this circuit. Uh, the select input here chooses the ALU operation, and I'll be switching between different modes like one, which is add, and two, multiply, and three for multiplying the most significant, four for divide, and so on. The ROM, which is the read-only memory, provides the inputs. So I set address A and address B uh, to pull values from ROM 0 and ROM 1 or ROM 2 and ROM 3. So let's first I will do the mode 1 for addition. So let's switch this to mode 1, and then I'm going to set ROM 0 um, to 3. Okay, let's do that. So ROM 0 to 3, and then let's set ROM 1 to just 1. So 3 and 1. And then we want the address B to read ROM 0, which is already it's on 0, and we want address A to read ROM 1. So we're going to switch it to ROM 1. And then so I'm going to set the output to ROM or RAM 5, which is over here, and basically we just have to change this to 5 so that our result does A plus B and then outputs it out to RAM 5. And A is from ROM 1 and B is from ROM 0. So let's try this out. Let's set our auto clicker on so that the clock keeps going. And then we're just going to start it. And as you can see, ROM or RAM 5 now has a value of 4, which is 3 plus 1. So our result went from this data bus all the way into the decoder and got decoded through the processor through the ALU. And since this is enabled, and the value is able to go all the way from down there to the data bus to the RAMs. Now I'll be trying to do division. So let's go to mode 4, and I'll be dividing the value 7 divided by, let's say, 7 as well. So it should give me a 1. So 7 divided by 7 is 1. So let's start this, and as you can see, our value goes down to RAM 6 and gives us a 1 because I set the address output to 6. And finally, I'll test mode 4 for multiplication. Instead of using new ROM values, I'll reuse the results from RAM 5 and RAM 6. So we have 4 times 1. So let's say RAM 5 and 6, and I want that result to store in RAM 7. Okay, so it's going to multiply it only if I switch the mode to multiply. So let's have it multiply, which is mode 2, start, and we got a value of 4 in RAM 7, which is 4 times 1. On the side here, I also included my K-maps and my equations for the state transition. I used the state table included in the video for the microprocessor, and I got these K-maps for my D1 and my D0, and then for the read and the accumulator out, and then got the K-map for the write and the demux, and then for the clear registers. And these were the four steps that we were using: idle, load B, and load A and store. And yeah, as you can see, this circuit functions the way it's supposed to be. And thank you for watching.